Today we're going to subtract mixed numbers with regrouping. But before we do that, let's do a little bit of review. Here we're going to have to regroup when we subtract because I cannot do my ones place subtraction. I cannot have 1 and subtract 5 from it. So I'm going to regroup and I'm going to make this one into a 0. I'm going to give that group of 10 to my ones place, and this will become 11 ones. Now 11 ones minus 5 gives me 6. Here again, I cannot subtract my ones place. 3 minus 5, I can't do it. So I'm going to borrow or regroup from the tens place, leaving 1 10 behind. And I'm going to give 10 to the ones place, so this 3 now becomes 13 ones. 13 minus 5 gives me 8. 1 minus 1 is 0. Here we regroup again. Look at the place value. 1 minus 9, I cannot do that, so I'm going to have to borrow or regroup. Take away 10 from there, so now I can give 10 ones here, and I have 11. 11 minus 9 is 2. 1 minus nothing is 12. So just a little review for us on our regrouping or our subtraction. Let's look at another problem here. Subtract. Make sure you show your work and use a common denominator. Well, what value could I replace 1 with so that I could do this math? I know I need a common denominator, so what minus 1/3 could I use that has the same value as 1 whole? What value could I use for 1 whole where I could subtract 1/3? Well, if I want a common denominator, why don't we just use the denominator of 3? How can I now make this fraction have a value of 1 whole? Well, I can call it 3/3 because we know 3 divided by 3 is 1 whole. Now that we have a common denominator, we can do our subtraction. 3 minus 1 gives us 2, and we keep our denominator. We're going to use this way of thinking a lot in this lesson. How can I rewrite the number 2 as a sum of ones? Well, I could say 1 plus 1 is 2. How can I rewrite the number 3 as a sum of 2 and another number? Well, 2 plus what is 3? Well, 2 plus 1. How can I rewrite the number 4 as a sum of 3 and another number? Well, 3 plus 1 is 4. We're going to use this idea and make it very, very similar to what we did here. Could I make this so that I had a fraction piece there? Well, let's say I wanted to use a denominator of 3 like I had in that last problem. I could make this as 1 plus 3/3. I could rewrite this as 2 plus 3/3. I could rewrite this as 3 plus 3/3. They have the same value. It just looks a little different, which will help us in some of our math today. So let's look at this first problem. 3 minus 1 2/3. So we start with our 3, 1, 2, 3, and we're just going to make it look a little different. Here's my 3. Well, I can write 3 as 2 and what? Well, in our first method, we're going to use a model. My denominator here is 1/3. So I'm going to go ahead and take this third box, 1, 2, 3, this third box, and break it up into thirds. Did I change the amount of boxes that are shaded in? No. But what's the value that I have here shown by my model? I have 1, 2 holes, and I have how many thirds? I have 3/3. Is 2 3/3 the same as 3? Well, 2 3/3 is the same as 2 plus 3/3, which is the same as 2 plus 1, which is 3. Now that I have this common denominator here, I can cross out 1 2/3. Let's go ahead and do that. I'm going to cross out 1 whole, and I'm subtracting and taking it away, and then I'm going to subtract 2/3, 1, 2 out of the 3. What are we left with? We're left with 1 whole and 1/3. One method is to make a model. The second method is to borrow 1 whole and regroup. So what we'll be doing here is borrowing from the whole and giving to a fraction piece. Well, here's my problem, 1 minus 1 2/3. I want to rewrite this so that way I have a common denominator and I have a fraction piece. Well, what we did up here was we said, okay, I'm going to have my thirds. And so now I have 3/3 and I'm going to write 2 3/3. This again has the same value as that, minus 1 2/3. Let's write that vertically so that it's easier for us to do our subtraction. 3/3 minus 2/3 gives me 1/3. 2 minus 1 gives me 1. My final answer is 1 1/3. So here we were able to borrow from the whole so that way we could do our subtraction. Similarly to when we borrowed from our tens place to give to our ones place to be able to do the subtraction. We can't add or subtract fractions without a common denominator. Let's remember that as we go through this problem here. We can't add or subtract without a common denominator. So what common denominator would you like to use? We have 1/3 and we have 1/2. Well, let's see. Okay. 3 can multiply to be 3, 6, 9, 12, and so on. 2 can multiply to be 2, 4, 6, 8, and so on. I see a common denominator can be 6, which we could also come up with just by multiplying 3 and 2. Okay, so my goal is 6. I'm going to use my giant 1 to help me create that equivalent fraction. 3 times what gives me 6? Well, 3 times 2 is 6. Since I don't want to change the value here, we're going to make my numerator the same. 1 times 2 is 2. 2 times 3 is 6. Again, I don't want to change the value, so my numerator is the same. 3 divided by 3 is 1 whole. 1 times 3 is 3. So my new problem becomes 1 2/6 minus 3/6. Well, can I have 2/6 and take away 3/6? No, I cannot. So we need to borrow from this ones place and give to the fraction piece so that we can do our subtraction. So let's look at our model. Here we have 1 in our 2/6. 1, 2, 3, 4, 5, 6, 2 out of 6. And I need to take away 3/6. Well, I can take away 1, 2, but I need to take another 6 away. So we'll end up breaking this whole up into 6 as well. Now that I have all 6, I can do my subtraction. Okay, well, how many 6 do I have now to start with? Let's see, this gave me 6/6, and I already had 2/6, so that's a total of 8/6. 8/6. So my problem now became 8/6 minus 3/6. Cross off our 3/6, and we're left with 5/6. We're left with 5/6. How this would look if I borrowed from the whole and did not use my model would be to write this as 6/6. That's my 1. I'm taking it away. It becomes 6/6. I'm going to add that to that 2/6. So now I have 8/6 minus 3/6. 8/6 minus 3/6 gives me 5/6. Gives me that 5/6. So we borrowed from the 1, gave to the fraction piece, and we were able to do our math. Before, we were not able to do 1 and 2/6 minus 3/6 because I cannot take 3 away from 2. That's why we had to borrow in this problem. Let's look at the bottom problem. Again, we cannot subtract fractions without a common denominator. We can't add or subtract them. So let's look here. We have 3 1/4 minus 2 1/2. Well, I want to make a common denominator. 2 can multiply to be 2, 4, 6, 8, and so on. 4 can multiply to be 4, 8, 12, and so on. A common denominator I see could be 8, but the smallest one is 4. So our goal here is going to be 4. I'm going to multiply by a giant 1, so I get an equivalent fraction. I don't change the value. 4 times 1 is 4. 1 times 1 is 1. 2 times what is 4? Well, 2 times 2 is 4. 1 times 2 is 2. We didn't change the value of the fraction, it just looks a little different. So let's rewrite our problem with our new denominators. 3 1/4 minus 2 2/4. Notice our model is 1, 2, 3, and 1 out of 4. So that's what we're starting with here. Can I cross off 2/4? No, so I'm going to have to borrow from my model and make more fourths. Cut that into fourths. Okay, and now you can see we have 2 5/4, and I can now take away 2/4. 1/4, 2/4, and my answer is 2 3/4. Oops, I'm sorry, I forgot to take away the whole of 2. That was 2/4. Now let's take away our whole of 2, and I'm left with a total of 3/4. 3/4. Mathematically, with borrowing, how would that look? Well, I would borrow from the 3. The 3 would then become a 2, right? How many fourths did I take away to borrow? I took away 4/4. Well, 4/4 plus 1/4, 4/4 plus 1/4 gives me 5/4. This was 2. I took away a whole to give here. Plus that 1/4, 4/4 plus 1/4 gives me 5/4. And I can rewrite my problem now. Let's rewrite it vertically. 2 5/4 minus 2 2/4. Can I do this math of 5/4 minus 2/4? Yes, I can. 5/4 minus 2/4 is 3/4. And 2 minus 2 is 0. So again, I get that nice answer of 3/4. We borrowed from the whole, gave it to the fraction piece, and then we were able to subtract.